let's simplify this rational expression here by actually rationalizing, okay? So we have 2x times y divided by cube root of 16 x y to the 5th power. Now to rationalize it, that means at the end of the day, we do not want to have any radical at the bottom of the fraction. At the denominator, we do not want to have the radical, the cube root. We don't want it, all right? So to do that, because we have a cube here, we're going to multiply this rational expression by the bottom piece. We're going to make another fraction, and then we're going to do it twice, all right? So that means what? So that means we're going to have 16x y to the 5th cube root of that over the same thing, 16x y to the 5th, all right? Then times again, cube root of 16x y to the 5th over, again, cube root of 16x y to the 5th. Now, if you guys remember a little bit, when we rationalize expressions that have square root, we multiply the original fraction by the bottom piece, we make it a fraction, then we do it once. But when it comes to third power, we got to do it 3 times y. Because remember, we said we want to do what? Make sure that we do not have a radical at the end of, the day, right? So that means we want to remove the cube root. But to do that, we need to multiply the same thing by itself 3 times. That's the reason why we're doing this. Okay? So let's continue. So this one is going to give us what? So the bottom piece is easy because we're multiplying the same thing 3 times with the cube root. So we're going to end up with only the bottom expression. All right? So that one is a done deal. So that means if we go to the bottom piece here, so we end up with what? 16 times x times y to the 5th power. Finish. Okay? Now, when it comes to the top expression, what's going to happen? So the 2xy is still going to be there, 2xy. And now, we're multiplying these two here. Okay? So that means we're doing 16 times 16. All right? So under the radical, so 16 times 16. So we can also break it down. So it's going to give us actually 256. But we don't need the 256 because we need to break it down also afterwards. So it's better if we can already reduce these ones. Okay? Break them down. So 16 is what? 16 is 2 to the 4th power. All right? So it's like when you have 2 to the 4th power times 2 to the 4th power. And then x times x will give us x to the 2nd power. Okay? And then y 5th times y 5th is going to give us what? Y to the 10th power because you're adding the powers. Remember, when you're multiplying the same variables, you add the powers. All right? So, cube root of that. We good so far? Okay? So very interesting, right? So then we come back here, we said this is equal to, we need space. So this is equal to what? So now we're going to break down whatever we have inside there. So we know that 2 to the 4th power times 2 to the 4th power is going to give us what? 2 to the 8th power. So we have 2x times y, cube root of what? 2 to the 8th power. All right? Then x to the 2nd power, y to the 10th power. Over 16 times x times y to the 5th power. Okay? Then this one will be equal to what? So now we can remove anything that is a perfect cube going to go outside, and anything that is not a perfect cube will stay under the radical. Okay? And how do we do that? So the 2xy stays 2xy, correct? And now we have 2 to the 8th, so, and then cube root of it. So please your attention. So what do we do? The easiest way to do this one, is either you can break it down inside and then take it outside, or you can also divide it. But so let's break it inside. That means what? That means 2 to the f can be broken down as 2 to the 6th power, which is going to be a perfect cube, and then times 2 to the 2nd power. So 2 to the 3rd power, 6th power, times 2 to the 2nd power. Okay? X to the 2nd power, there's nothing you can do about it, ladies and gentlemen. As we've been dealing with radicals before, anytime the power inside is lower than the index, you keep it there. Nothing you can break down about it. So x to the 2nd power is going to stay x to the 2nd power. And then how about y10? So y10 can be broken down as y9 times y1. Okay? And then you have your cube root back over 16x to the y to the 5th power. We're taking time to do this, okay? We're taking time to do this one at a time, okay? So, now, why is it that 2 to the 6th power is a perfect cube? Because 3 can go into 6 evenly. That's the reason why. Or 6 can divide 3 evenly. So it's going to divide 3 evenly twice. So then that will go outside. So that would be 2 to the 2nd power outside. Okay? So 2 here, we multiply 2 to the 2nd power. Because 2 power 6 becomes 2 to the 2nd power outside. 3 goes into 6 twice. That's the reason why. Okay? What about x to the 2nd power? We say there's nothing we can do about it. So these are the perfect cubes. Okay? And then what about the x? The x will stay under, so I'm bringing this one down, so the x is x. All right? So how about y? So the y also is y. We bring this y also out here. Now, 3 goes into now how many times? 3 times. So it's going to be 3y, to the 3rd power outside. Okay? And then we have our cube root back. This one stays in. So that's 2 to the 2nd power, that becomes a 4. 2 to the 2nd power, that becomes a 4. X to the 2nd power stays in. And y to the power 1 also stays in. And this one is over. 16x y to the 5th. Very interesting problem, right? Lovely problem. So now we can always combine whatever we have here. And then after that, simplify. So 2 to the 2nd power is what? Is 4. 4 times 2 is 8. So you have 8 here. All right? And then how about x? So x stays x. Nobody to play with. Y times y to the 3rd is going to give us y to the 4th. Okay? Then cube root of 4x second y. See how this is becoming even more interesting? Then you have 16x y to the 5th. Ladies and gentlemen, now you can simplify these here. Whatever possible. That means what? 8 and 16. 8 can go into 7 one time, can go into 16 twice, right? So you end up with what then? So you end up with, at the bottom, so you end up with 2 at the bottom for the numbers, then x out, y4 divided by y5, you subtract it, so that will give you a y1, but at the bottom, because if you move the lowest one to the largest one, so that would be 5 minus 4, okay? So you end up with y1 at the bottom, okay? So it's 2y at the bottom, and then what is left on the top? So on the top, you only have cube root of 4 x to the 2nd y. Anything else that we're missing? No. All right? So this one, so we have y left, and that's why we have y at the bottom, and then everything else is this one. All right? So we end up with cube root of 4, x to the 2nd power y, divided by 2y, and that'll be our final answer. Okay? How interesting problem, right? So take time, go one at a time, and then break it down.